Okay guys, sorry that I am not in class today. I am in the building, but I'm doing personalized learning trainings for some of the teachers. So I might be able to stop in later to check up on you guys, but it depends on how long the trainings end up taking. So first off, let's go ahead and open up to page 48. We are starting a new unit today, which everybody knew about. So we are starting our Radicals Part 2 unit. On page 48, let's go ahead and write down our review and test dates. I'm trying to get back into the groove a little bit here. So our review session will be next Wednesday, May 29th, and your test will be next Friday, May 31st. So this is a short unit, but this is all material that you need to know in order to succeed next year in geometry. They kind of expect that you guys know this information coming in, so they don't have to spend as much time on it reviewing it next year. All right, hopefully you got that written down. Give you a few more seconds. Okay, so now we are on page 52. Before I actually start doing the notes, quick reminder, if I ask you to pause the video, please actually pause it and do the work I'm asking you to do. And then also, if you have questions or anything as you're going, you can pause the video, check in with a partner if you have that question, or if I'm maybe moving too fast, feel free to pause it on your own time as well. So let's go ahead and get started. Simplifying radical expressions, or you'll hear me call it rationalizing the denominator, RTD. It's basically whenever we have a radical in the denominator. We are not allowed to have radicals in the denominator in simplest form. And I mentioned this when we were in our radical unit before. So what we have to do is we have to eliminate the radical from the denominator so that it's no longer there. And here in this first example, we'll see how we do that. So our original problem was 5 over the square root of 7. In order to get rid of the square root of 7, because again it's not allowed in the denominator, we are going to multiply by the square root of 7 over the square root of 7, because remember that just equals 1. So I'm not changing the meaning of this problem because I'm essentially just multiplying by 1. When you do that, you end up with the square root of 49 in the denominator, and you now have 5 square roots of 7 in the numerator. So we have just multiplied and combined our like terms. Remember, 5 and square root of 7 are not like terms, so we cannot put them together. And now we simplify whatever we can simplify. And one thing I see we can simplify is that square root of 49, and it just gives you 7. So your final answer is 5 square roots of 7 over 7. Again, simplest form is as long as we do not have a radical in the denominator and as long as your fraction cannot simplify. And by that I mean we have 5 over 7 as our actual integers, and 5 and 7 do not simplify as the numerator and denominator, so that is our final answer. All right, so let's go ahead and do number 1 together. And I'm going to flip my computer, so give me 1 second.